All right, this is Precalculus, Chapter 8, Lesson 2, starting on page 529. Look at the title of this lesson, Inverse Trig Functions. Okay, so let's go back. When we had something like this, and I asked you, what is the inverse of that function? What did we do? We swapped the x and the y. When we looked at this, how did we solve for x? We did the what? The inverse. It's the same thing. We're swapping the x and the y's. Okay, but there's a problem. That's right. So we did this, right? It's swapping the x's and the y's. And our calculators did it. Okay, there's a problem when we get to the sine and the cosine. Well, you know, it goes on and on and on. And it goes on and on and on, right? Okay. So listen carefully. 1/2, let's just say, is here, right? But it's also here. How many solutions of 1/2 are there on the sine curve? Infinite. But when I do the inverse and put that in my calculator, how many solutions does it give me? 1. It gives you 1, right? Wouldn't that 4 be nice? It only gives you 1. Because when you look at the inverse, your calculator looks at functions. What makes an equation a function visually? It passes the vertical line test. Okay? All right, so you're listening closely. I really want you to listen with everything that's in you. So, to know if an equation is a function, you can look at it visually and do a vertical line test. To know if a function, so this is a function, passes the vertical line test. To know if a function has an inverse, you do a horizontal line test because your x's and your y's change. Does that make sense? It's as though we do this and the x's and the y's change. So, to test if a function has an inverse, you do a horizontal line test. Okay, what's the problem with this horizontal line test? Too many. Right. So x now has multiple y's. And that doesn't work with a function. Except we can limit the domain. So this is the key point. We can limit the domain. What is the domain? The domain is the what values? X values. Okay, so let's just look at the sine curve. We're going to limit the domain. All right, it goes up to 1, down to -1, starts at 0, pi over 2, pi, 3 pi over 2 to 2 pi. All the way back to -pi over 2. All right, so where could I limit the domain? Just look at a slice of the sine curve such that I covered every value between 1 and -1 only one time. Like it didn't repeat 1 twice or 1/2 twice. Abby?
Pi over 2 to 2 pi over 2.
Yeah, I could go from here to here, right? That is correct, except we shift it back. And we go from negative pi over 2 to pi over 2. So when you solve, when you do shift sign on your calculator, you know the solution it's giving you? It's giving you between negative pi over 2 and pi over 2. So when we look at the inverse of the sine curve, we're going to limit the domain between negative pi over 2 all the way to pi over 2. Okay? So that resultant function, the resultant inverse becomes a function. All right. So normally we're like our xy's are negative pi over 2, negative 1, right? That would be my coordinate points. You agree? And 0, 0 would still be 0, 0. And then pi over 2 would be 1. When we look at the inverse, they swap. So here's the inverse. It would be negative 1, negative pi over 2. What's the value of pi over 2? Like about 1.5 something-ish, right? Okay, we're just going to say 1.5, even though it's not exact. 0, 0 doesn't change. 1 pi over 2. So it's a little more than 1, right? All right, so let's look at see what happens to the inverse of this curve, what it looks like. So negative 1 is a little less than pi over 2, right? And we're going down to negative pi over 2, so it's a little further down. I believe there's a picture in your book, maybe.
Switch the x and the y axis?
The axes don't change, the coordinates change.
Yeah, but wouldn't it just, instead of it being like this, it would be like this?
Well, and we're going up here. Instead of it going like an S, it's now like a backwards S.
Yeah, so now it's, yeah, it looks more like a tangent. Almost.
It does look more like a tangent curve, except it really does kind of go like that. Yeah, look at the top of page 530. That is that's not the inverse. The inverse is on the bottom. In that green box. You see the inverse? Okay, it does look more like the tangent. All right, so that's what this blue is, what is called the arc sine, or we know it as sine inverse x. Our sine inverse, really we've swapped them, right? But that becomes the x. All right, so does that make sense with the sine? Okay, when we look at the inverse sine, what are we limiting our domain to? Between
Negative pi over 2 to pi over 2.
Thank you. Negative pi over 2 to positive pi over 2. All right? So what quadrants are we in? On the unit circle. What is between 0 and pi over 2? What?
Would it be 2 and 3?
One.
This one is quadrant 1.
Yeah,
That was quadrant 2.
Which one is this one?
3.
We're going backwards.
Yeah, 3. 4. Oh, 4.
4.
1, 2, 3,
What?
No, how could that be
Wait.
4?
Because you go backwards.
Because you're going backwards. Let me get my unit circle.
It would be negative pi.
Look. Instead of going
From 0 to
up here, we're going
to quadrant 4.
down here.
Yeah, so that's.
This is quadrant.
0 to
Oh,
negative pi over
it
2.
stays the same. Yeah,
Quadrant
great. I got it.
You got it?
No.
Nope.
You don't have it.
And why is that still quadrant 1? Because quadrant 1 and quadrant 4 aren't across from each other.
Well, they're right next to each other. They are. Remember, we can go positive or we can go negative.
Then it would still be quadrant 3.
How do you go?
But it's different. The quadrants
Okay.
are different on here.
Okay, find negative pi over 2 on your, what is negative pi over 2 here?
3 pi over 2.
Okay, so between 0 and negative pi over 2, where's that on this unit circle? Where? What bottom?
The bottom of the circle.
Which quadrant? 1, 2, 3, or 4? Yes. 4. Okay, look. If I'm going around positive, the unit circle.
Wait, draw the two quadrants.
What?
Where's the other 2
Yeah,
quadrants
where are
on
the
that
two
graph that
Oh,
we
I
have?
see what you're
Why can't we look at quadrant 2?
Because sine's positive.
Oh,
Because the sign is positive, we repeat the same values. The output is the same.
there, yeah, you're right.
And so now your x has more than one y.
That's.
Okay? And we don't go 1 to 3 because then we have to go 1, skip this part, 3. That's harder. So we just go back to 4 because how is the sign outputs in the first quadrant different from the sign outputs in the fourth quadrant?
Negative in the fourth.
Negative in the fourth, positive in the first. So we don't repeat the output. Every x has one and only one y. It did.
Wait, so where are the other 2 quadrants on that?
Okay, when we're looking at inverse, what did I say we're going to do? We're going to limit
Limit
the domain.
Oh, so we don't need the other 2.
We're not going to look at them in this moment. In this one moment, right here. Know that when you're looking at the inverse sine, you're only looking at what 2 quadrants? 1 and 4. We're going around to pi over 2, positive, and we're going to go down on your unit circle because the output is different. So now we have, even when we swap the x and the y's and look at the inverse, every one has a unique output. So when we limit the domain, when we look at the inverse of the sine, our output, our solutions, our x value is going to, this is going to be in what quadrants? It's either going to be in quadrant 1 or it's going to be in quadrant 4. Got it? Yes.
On the unit circle at 0 to pi, the cosine is 1 and the sine is 0. How come that doesn't switch when we have the inverse and it doesn't switch so the sine starts at 1 and the cosine starts at 0?
We're not swapping the cosine and the sine. We're only looking at the sine.
Okay.
Got it? Because the sine starts at 0,
No matter what.
0.
Okay.
Look, it's at 0, 0 degrees, or 0 radians, and the sine is 0.
So these
So 0, 0
it doesn't switch. no
doesn't
matter what.
swap. That's right. Okay, so when we look at the inverse, what 2 quadrants are we looking at?
1 and 4.
For the sine, we're looking at the first and the fourth. How do I know what quadrant my solution is going to be in? When I look at, let's just suppose I had the sine of x is 3/4. Okay, everybody look. Sine of x is 3/4. What quadrant is x going to be in?
First
The first, because it's positive. It's going to be in quadrant 1. Got it? What if I had the sine of x is -2/5? What quadrant is x going to be in?
4.
Quadrant 4. Why?
Because it's negative.
Because the output is negative.
That makes more sense.
You got it?
That makes more sense.
You got it? Okay. All right. All right. Yes.
I guess what I'm getting a little confused is that I thought the fourth quadrant was like directly underneath the first quadrant.
It is on the unit circle. But when we graph it, all right, what is on the x-axis when we graph it? Radians. So it's these radians. And your y value is the ratio. So your x-axis was the radians, your y-axis was the ratio. When we swap them, now your x-axis becomes the ratio and the y-axis becomes the radians. Yes.
I know this isn't relevant in this problem, but if I'm thinking about it correctly, the third quadrant is under the first quadrant with these problems, right? Even though we're not using that here, wouldn't quadrant 3 be under quadrant 1, and quadrant 2 would be beside quadrant 1?
Pretend that they don't exist.
Hey, so we just don't.
We stretch this out on a graph. This looks different than the graph, right? So we start at 0, right? This doesn't look like the sine curve here. It's the circle, right? But the circle represents the radians and the ratio. The radians we put on the x-axis, the ratio we put on the y-axis. When we swap them, it's just the inverse of that. Okay, so when I graph that sine curve, this is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. So when I go backwards,
Oh, that makes so much
this
more sense.
is quadrant 4.
That makes so much more sense.
It was not making sense before because I think it was, we were just trying to picture the circle.
Thank you. I will do it like this. Okay, so this is the way to teach this. Remember next year. Okay, does that make sense now?
Yeah.
Right? Okay, so it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. When you go backwards, it's 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1. There's no quadrant 5.
You should have just
Okay, well now I did it. So there we go. Woohoo! Okay. All right. All right.
I think we should take a break after.
No, we can't. Oh my goodness. Let's do example 1. Okay. Example 1 says the sine inverse of 1/2. So what quadrant should I be thinking of?
Oh,
The first?
The first quadrant. So where in the first quadrant is the ratio 1/2? Do you know?
Pi over 3.
Pi over 2. Oh,
Pi
maybe
over
pi over 2
6.
and
Must
pi.
be.
Why is it pi over 6?
Because
Cosine
it's
counts down.
cosine.
It counts up. 0, 1. Got it?
So that's all we have to do.
This is your answer. Woohoo!
Oh, that's it.
That's the answer. That's the answer. That's the answer.
Math
For now.
Math got like 10 times harder than 10 times easier.
Okay. Look at B. What if I did the inverse negative square root of 2 over 2? What quadrant are we going to look in?
4.
Fourth quadrant. Because we're only, when you see that inverse, what 2 quadrants?
First and fourth. Okay.
for the sine. If it's positive, we're looking at quadrant 1. If it's
Negative is looking at
quadrant 4. So, and we're only looking, everybody look, we're only looking between negative pi over 2 and pi over 2. So when I go negative, that's going to be negative what?
pi over 4.
Negative pi over 4. Because that is coterminal. That is coterminal to 7 pi over 4, is it not?
Yes.
Yes. But remember, we're limiting our domain. So, everybody look, 7 pi over 4 would be a wrong answer. Because we're limiting our domain between negative pi over 4, negative pi over 2, and pi over 2.
So we can only use like the original.
You can only use values between negative pi over 2 and pi over 2. Got it? Okay. We're going to stick with the sine. All right. Let's look at the next example. Look at the properties on the top of page 532. It says the inverse of the sine of u is going to be u. Okay, so let's think about this. What if I did the inverse of the sine of pi over 4? Okay, what's the sine of pi over 4?
Is it square root of 3 over 2?
Square root of 2 over 2. Right? We saw from the inside out. Right? What's the inverse sine of the square root of 2 over 2?
Pi over 4.
So, the inverse sine of the sine of pi over 4, those are the same. You see that? Because we're asking, what are we asking for? What are the radians of this? Because we've swapped them. Normally we're asking what's the ratio, but inverse says, what are the radians of this? Well, the radians of this are these radians. Got it? So, the inverse sine of the sine of 1.23, what does that equal? 1.23. I had to think of something less than half a pi. Make sense? All right, look at the next piece in the box. It says, all right, I'll erase this one. It says the sine of the inverse sine of v equals v. All right, so let's do the sine of the inverse sine of negative 1/2. Okay. What are we looking between? Between what two values?
Negative pi over 2.
And, okay, what quadrant is this going to be in? Fourth quadrant. So what's the sign of negative? What is the inverse sign of negative 1/2?
Pi over 6.
No.
Positive or negative?
Pi over
Negative. Negative pi over 6. What's the sign of negative pi over 6?
negative 1/2.
It's the same. Got it? So inverse sine equals the u. Sine inverse equals that value. Yes.
Why does the book say if it's between negative 1 and 1? Or that one?
Okay, if it's between negative, because how high does the sine curve go up?
Just
1. How low does the sine curve go down?
1.
Negative 1.
Okay.
It's got to be between negative 1 and 1. Okay, so we're going to look at the next example and see how these play out. Because when we do the inverse, what quadrants are we in?
1 and 4.
1 and 4. Okay, so look at this one. The inverse sine of the sine of pi over 6. What does that equal? Quickly. Pi over 6. This only works when this is in quadrant 1 or quadrant 4. So it's between negative pi over 2 and pi over 2. How is this different?
Because it's not between negative
The inverse is never going to be in any quadrant other than first and fourth. All right, so what is the sine of pi over 5 pi over 6? What quadrant is this in? 5 over 6. It's in quadrant 2. The sign is positive. The ratio is still 1/2. Okay, what's the inverse sine of 1/2?
Pi over 3. Pi over 6.
Okay, so when doesn't this work? When this value is not in the first or the fourth quadrant. You have to work inside out. Yes.
So say it was like 3 pi over 4, like the sine of 3 pi over 4. Would the answer be pi over 4?
Yes.
So it's like
Correct.
the parent power.
Right. 2 goes to 1. 3 goes to 4.
Okay.
Yes. Okay, that's great tying things together. Right, because what if this were now 7 pi over 6? What's the sine of 7 pi over 6? What quadrant is this?
Oh,
That's 4.
third.
7 pi over 6. Third. Quadrant 3. Right, I'm working inside out. All right, so quadrant 3, the sign is positive or negative? Negative. So the inverse sine, negative 1/2. What's the inverse sine, negative 1/2?
Pi over 6.
Negative pi over 6.
She's have to go back to the.
So you have to work inside out. Knowing that it's in the third quadrant, my answer better be in the fourth quadrant.
Nice. That sounds good.
Okay? Got it? Okay. That's just one piece of this lesson. It's okay, we're going to get this. We're going to get this.
How many
Okay.
pieces are there?
Tangent is easy.
Oh.
Cosine.
No.
Sine is the hardest. Sine is the hardest. All right, now let's look at the cosine. What quadrants are we in with the sine?
First and fourth.
Between what pi and what pi?
Negative pi over 2.
Got it? So I'm never going to have a solution that says something like 5 pi over 6 or anything greater than pi over 2 or anything less than negative pi over 2. So I'll never have a solution that says like negative 3 pi over 4. Got it? Okay. Let's look at the cosine curve. We also have to limit the domain of the cosine curve. The cosine starts here, here. All right, so this is quadrant 1, quadrant 2, quadrant 3, back to quadrant 4. All right, we want to limit its domain as well. The sine is easier because look, for the sine, we just limit the domain. Everybody look, everybody look. It doesn't repeat. It begins repeating once we get to quadrant 3. So if we just limit here, there's no repeats. You see that? Everybody see that? So what are we limiting the domain for the cosine?
0 to pi.
Quadrant 1 and 2. Right? Yes.
How come we can't limit it to quadrant 3 and 4?
You could. Theoretically, you can. You can. But because of the way the unit circle is, it's always easiest to include quadrant 1 because that is always the quadrant we go back to. That's why with the sine we go back to quadrant 4. I wouldn't go from 1 to 3. So I'd always use consecutive quadrants. So for the sine curve, we're going to restrict the domain between 0 and pi. All right? So inverse cosine, we're limiting the domain to be between 0 and pi. All right? So every one of my solutions for the cosine is going to be between the values of 0 and pi. Look at example 3. Okay, this one's so much easier. Sine was so much harder. But now that you've got this thing, if it's in quadrant 1, is my ratio going to be positive or negative? Positive. If it's in quadrant 2, my ratio is going to be negative. So that is the big hint. Look at example 3. If I'm looking at inverse cosine 1/2, what quadrant are we in? 1. Okay, cosine counts down. So it's 1, 3, 2, 1, half. So it's pi over 3. Remember, our value's getting larger. Our radians are getting larger. All right, cosine, here, it's 0, 1. It's pi over 6, square root of 3 over 2. It's counting down as this goes up, right? At pi over 4, square root of 2 over 2. At pi over 3, 1/2. This is the cosine. Remember, the sine counts up. It starts at 0, it goes to 1/2, it goes to square root of 2 over 2, it goes to square root of 3 over 2. You see how it's counting? The counting is different? Okay. All right. So it's pi over 3. What is the inverse cosine of 0? What is it?
2 pi.
It's pi over 2.
That's right.
Huh?
That's correct.
That is correct. It's pi over 2. Because once it gets to pi over 2, what's the cosine? 0. What do? We swap them. And this becomes 1. Yeah, I didn't write that last one in. All right, how am I going to figure out, well, let's just think about this. Cosine negative 0.63. How is this one different from the previous two? It's in radians, but is it on the unit circle?
No.
That is not on the unit circle. And it's negative, so my solution should be in quadrant 2. So it's going to be between pi over 2 and pi. But we have to do this in our calculators. All right, so make sure you're in radians. Make sure your calculator is in radians. And then do second cosine negative 0.63. What do you get? 2.25. Typically we're in trig, it's in 4 decimal places. All right. So when when this is not on the unit circle, then you use your calculator. Is 2.25 between half a pi and pi? Is this value between half a pi and pi?
Yes.
Yes, it is. It's between like 1.5 and 3.14. Right? Okay. All right. Now, look at example 4. Now we're mixing them. And I really want I'm not going to use V. I'm going to use an actual value. All right, so let's say we were looking for the sine of the inverse cosine of 3/5. All right, when you see something like this, draw the triangle. First off, what quadrant is this in? First, okay? So the sine, my answer is going to be positive, right? Okay, I draw it. The cosine is what over what?
Opposite over.
I should draw it like this, huh? Like going around the unit circle. It's adjacent over hypotenuse. So it's 3/5. There's my radians. We'll put X there. Okay? Can I calculate the opposite side? Yeah, I used the Pythagorean triplet. It's 4. All right, so what's the sine? What's the sine of this same angle? This same angle. Opposite hypotenuse. You see how we did that? Draw the triangle. You have to draw the triangle. Let's go the other way. And I'm just going to make something up. Well, I still just need to do a Pythagorean triplet because, yes,
Because that was an inverse cosine.
the sine wasn't inverse, the cosine was inverse.
Why wouldn't it be the hypotenuse and the 3 and 5? Would that be flipped because it's an inverse cosine? Like, would the 3 be the am I thinking of it wrong? No.
I know it's in the first quadrant because it's positive.
Uh-huh.
So the adjacent's 3, the hypotenuse is 5. I'm going to label it X.
So the inverse cosine is not the same as the cosecant, or that's this cotangent.
Correct.
It's not.
It's not the same thing.
Okay, I thought it was the
Correct.
same.
Correct. It is not. Inverse says we're swapping the X and Y. The cosecant is literally 1 over the cosine. No, 1 over the sine, cosecant. All right, so when you see something like this, what are you going to do? You're going to draw the triangle. Okay, now, what if this were negative? What if this were negative? What quadrant? We're now in 2. Here's my angle. It's still opposite, adjacent. There's my -3 over my +5. What's the 4? Positive or negative? I'm in quadrant 2. The sign's going to be positive or negative?
Positive.
That's positive. It goes up on the y-axis. So this is going to be 4/5, even though this is negative. Because we're in quadrant 2 and the sign is positive. Got it? Okay. Let's do the cosine of the inverse sine of I just have to do a Pythagorean triplet. Okay. What quadrant is this in? Wait a minute.
It's the fourth one.
It's the fourth because it's the inverse sine. It's the fourth. So there's my positive x-axis. There's my angle, right? It's opposite over hypotenuse. Got it? So what's this side, the length?
8.
Positive or negative? Think,
Negative.
think, x, y.
Oh,
Positive.
yeah, positive.
So what's the cosine?
8 over 10, yeah.
Positive, because we're in the fourth quadrant.
Yeah.
Do you see how you have to think about what quadrant you're in? Okay. Inverse tan. Easy, 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 easy. Because one cycle of the tan passes the horizontal line test. Between negative pi over 2 and pi over 2. See how it passes it? So we're just going to look between negative pi over 2 and pi over 2. So this is quadrant. This one.
4.
Quadrant 4. What is quadrant 1? It goes 1, 2, 3, 4, or 4, 3, 2, 1, 4, 3, 2, 1. Remember? Okay, so we're going with this with the sine and the tangent. We're always looking in quadrants 4 and 1. Got it? Maybe? All right. Look at the box. It says the inverse tan of the tan of u is u. As long as u is in what quadrants? 4 and 1. So what is the inverse tan of the tan of pi over 4? It's pi over 4. Got it?
Got it.
So this is the same with the sines. The sine and the tangent always look the same when we're talking inverses. Okay? Okay, so I want y'all to think of this. I want y'all to think about this. We're not using our calculators because this is on the unit circle. What is the tan equal? What over what? The what over the what? The, okay. The sine over the cosine. Sine over the cosine. So for that ratio to be 1, what must be true, Isabella, about the sine? The numbers have to be the same. There's only one place where the sine and the cosine is the same, and that is at pi over 4. It's positive, so is it positive or negative pi over 4? It's positive pi over 4.
And you're wrong.
Got it? Got it? Okay, how in the world am I going to do this?
Give up.
Calculator. When it's not on the unit circle, when is it going to be on the unit circle? When you see a square root of 3,
It's in radians.
or when you see a 1, or when you see a 0. This is when it's going to be on the unit circle. So what is the inverse of that?
1.5634.
Okay, there we go. Let's work the last example. Last example. It's like the ones that I just worked where we have to draw the triangle. You also have to draw the triangle here. I guess your book does draw the triangle. Okay. Cosine of the inverse tan, square root of 5 over 2. The tan is what over what?
Opposite over adjacent. Sine over cosine.
Or sine over cosine, opposite over adjacent. I'm drawing the triangle. Okay, it's the inverse and the ratio is positive. What quadrant are we in? What quadrant? 1. Okay, I'm going to draw my triangle. Got it? That's my angle. Where does square root of 5 go? Where does 2 go?
Yeah, right there.
Okay, I have to calculate the hypotenuse. Well, I don't really know. 2 squared plus square root of 5 squared equals that hypotenuse squared. That's 4 plus 5, which is 9. So it's 3. So what's the cosine of this same exact angle? Adjacent over hypotenuse. Okay?